we have here an ethonic acid solution. It's actually, well, it used to be just water with loads of sweets. Yeah, so there's loads of sweets that contain malic acid, citric acid, and sugars and stuff, and ground them up into a powder and just dump them in water. And over time, the bacteria have thrived in this water. And what's happened is over time, it's all started to break. Well, it's mainly the oxygen as well coming in to the solution. I don't know if it's. I don't think it would be biological, but basically, all the sugars, not all the sugars, but some parts of it have turned into ethonic acid, and ethonic acid is vinegar. And this is sodium carbonate. It also has starch in it because it's for bakery. Some people call it bicarbonate of soda, which is a weird name to call it, to be honest. But as you can see, we add some in. Oh, that's cool. All starts reacting quite well as well. It's not amazing how quickly this reacts. It's really cool. Let's get a better shot of this. Yeah. Let's add some more. So what's happening here is the sodium carbonate is reacting with the ethonic acid. This is a neutralization reaction. You have an acid and a base. The base is ethonic acid, and the alkaline, which is the base, is the sodium carbonate. Now, most people might think, well, have an alkali is just being hydroxide ions. That's not the case. An alkali is something that can react with a acidic solution to produce a salt and neutralise acids, which is what sodium carbonate does, and that contains no hydroxide at all. And the gas producing is carbon dioxide. There's quite a bit of that. Yeah, I've had this for some time now. I haven't really, never really knew what to do with it until now. Let's see. It's kind of cool, just reacting all the way with the vinegar. And I'm hoping, because the end product of this is sodium ethonate, and I'm quite interested to see if I can get crystals of sodium ethonate. Although I don't really know what I'm going to use it for. I mean, the main purpose of this was just for fun. But I guess I could see if I could use some sodium ethonate in the future. Yeah, it goes in. It's actually, yeah, quite a lot of it in there. Just all reacting away. That does produce quite a bit of the carbon dioxide, which has sort of like a sharp sort of smell to it. Although I don't think that is actually the carbon dioxide directly, but rather it reacts with the water, like the molecules of water that's in the mill, to produce an acid called carbonic acid, which then reacts further with your bodily tissues, so you get a that's why it's painful. Well, sharp smell anyway. I think that's the case. I'm not sure if that's true, but that's my explanation on it. I don't think it's actually the carbon dioxide itself. It's true. That's how your body detects when you need to breathe and stuff, because your hypothalamus detects the acidity of carbon dioxide, or carbonic acid, sorry, in your bloodstream. So cool. I mean, the whole reason why we have stalagmites and stalactites in caves is due to this carbonic acid, which comes when carbon dioxide dissolves in solution. Which means we also, even though there's a neutralization reaction going on, we're actually creating another acid, which is the carbonic acid in this. Which is kind of cool. Yeah. So that's going to produce quite a bit, hopefully, of the sodium ethonate. Just so cool to watch. You know. And there seems to be going in the water. I think this is an exothermic reaction, although I'm not 100% sure. But yeah, I think it is. Definitely. Probably. Because it's, what's it doing? Neutralization, so it's using some of it. But, yeah, I mean, this is very basic. This is a reaction that some people know about, especially if you have like those volcano kits when you were a kid. You have this sort of reaction going on in your model volcano. But yeah, you put this in a smaller jug, it usually froths over the side. Uses so much of it. It's just been doing this for quite a while and it's still reacting with the sodium carbonate. Just got to show there's quite a lot of vinegar in this. What I should have probably done is poured some of the vinegar out and kept the rest. I've already done it now, so there's no, I think I can't just go back. Wow, this is a very good way of producing carbon dioxide. Oh, I can smell it. Very sharp, acidic smell to it. I mean, if you ever want to know what it smells like, you can do. Or if you ever open a bottle of Coke and sniff in the fumes, which is the carbon dioxide, when it comes out, you can get it. Yeah, when Coca-Cola and things go in your body, like carbonic acid decomposes inside your stomach because of the temperature and the enzymes in the hydrochloric acid in your stomach reduces carbonate, that part of the carbonic acid, back into back into carbon dioxide, and that builds up in your stomach, and of course that's why you burp and you have loads of fizzy drinks. And when you burp and it goes into your nose, you get a really sharp pain in your nose, and that's because of carbon dioxide, which is making a carbonic acid, which is then reacting with your flesh. Well, that's nothing really to worry about because it's not that strong of an acid, but it still has to be careful. If you're wondering what that piece of metal is, that's a bit of aluminium. I wonder if it would react with it, but it's something cool to watch, really. And what I'm probably going to do later on is extract the sodium ethonate out of solution. I don't know how much it's going to really be just the ethonic acid. I think there is also the other acids still present. I'm in a mess. There's quite a lot in there. Yeah. Quite interesting chemistry. This is a reduction reaction. It's giving an electrons to the carbonate part, reducing it to carbon dioxide, also oxidizing the sodium with the ethonic acid to produce sodium ethonate. It's quite nice to listen to. It's just bubbling. Oh, I can definitely smell the vinegar. It's not as strong as it was before. But there's loads of vinegar in this. I'm just going to try one. I'm going to do one more. I'm really just doing this because I don't really know what to do with carbonate or this either. So just far just reacts the two because it would be something interesting to watch. So just a bit of chemistry really. It's quite cool. Anyway. Yeah. That at the back, by the way, in case you're wondering, is a Van de Graaff. I never got round to actually fully assembling it, but it's getting there. It's on a metal base, stupidly. I don't know why I chose that base. I mean, oh, I remember. It's because I wanted a charge reservoir, but obviously I could shock myself. And that at the back, I'm looking at the capillary reaction of the water. So, because this string is made of mostly cellulose, the adhesive forces of the water and the adhesive forces of the cellulose actually drag up the water because it's attracted to the cellulose molecules, and so the water literally is attracted through adhesive forces through the electrostatic force up the string, but also there's the force of gravity pulling it back down, so it only gets to a certain height. But I should see some crystals of sodium chloride forming, and that piece of blue tack is just a counterweight, just to keep it all in place. But yeah, that's really it really. I've been doing much. This is a aluminium hydroxide with gallium in it, because I reacted gallium aluminium alloy with water, which produces aluminium hydroxide and gallium and hydrogen gas. It's a really good way of producing hydrogen. It fizzes up a lot, like this reaction has with CO2, carbon dioxide, same thing. So yeah, and this weirdly reacts with the water as well, tap water for some reason. Not sure why. It's like bubbles, and I tried to react it with vinegar, which is ethonic acid, and nothing happens. So it must be something in the water that's doing it, or could also be hydrolysis. Although I'm not sure if that's the case, but it could be that the carbon dioxide is I don't really necessarily decompose, but because hydrolysis in water, although I'm not too sure, but that will be my explanation. But it definitely reacts with this vinegar. Yeah, the reason why it's changed colour like this is actually because of the starch, because it's not all sodium carbonate, it's got starch in it as well, diphosphates. Yeah, you get starch. So there's some more extra starch. Yeah, because hope you found this interesting anyway.